Hello friends, today we will discuss how to find the resultant of unlike parallel force system graphically as well as analytically. For that we will consider this problem. There are four forces 20, 40, 60 and 10 Newton. They are, they are parallel but of different directions, so it is unlike parallel force system. Now to start with, we will draw first. The first step is to draw a straight space diagram. First step, we will draw a space diagram. What is space diagram? Space diagram is the diagram in which the distances, the spaces between the forces are drawn to some suitable scale. So for that, I will consider the scale as say 1 centimeter is equal to 1 meter, and I will denote these forces the name according to the Bose notation. So to start with this 20 Newton force, I am drawing this 20 Newton force first. Here the length of the arrow is not to scale. In space diagram only spaces are given some suitable scale. So I am drawing the space diagram considering the 1 centimeter distance is equal to 1 meter, like this. So in space diagram this 20 Newton force is here given, it is as upward, then this is 40 Newton force, 60 Newton force upward, and 10 Newton force is also upward. The distance between the forces is marked as a to some suitable scale. See this distance. Here I am drawing 1 centimeter, this 2 centimeter, and this is 5 centimeter, which is given 2 centimeter. Actually it is 2 meter, but as the scale is 1 centimeter equal to 1 meter, it is 2 centimeter, it is 3 centimeter, and this is 5 centimeter. Now according to the Bose notation, I will note down the forces. The space created on the left side of this first 20 Newton force is as A space. This is B space, that is space between 20 Newton and 40 Newton force. This is C space. This is D space. And this is E space. Remember, the spaces are drawn to some suitable scale. The distance between the forces distances are drawn to some suitable scale, and the notation is according to the Bose notation, and this diagram is known as space diagram. Okay, now the first step is over. Now the second step. Second step is to draw a vector diagram. Vector diagram. In this, we select a scale to draw the force length. So here I will select a scale. 1 centimeter is equal to say 10 Newton. Now to start with the 20 Newton force which is upward, so I will draw 2 centimeter, and it is upward. Here I will use small letters A to B. 2 centimeter. Remember 1 centimeter equal to 10 Newton. So to represent 20 Newton, I am drawing 2 centimeter. Then next force is 40 Newton, that is BC, 40 Newton downward. BC is 40 Newton downward. So from B, draw a length 4 centimeter down. So B to C. BC is downward, 40 Newton is downward. From C to D, upward force is of 60 Newton. So I will draw 6 centimeter from C. Remember 6 centimeter from C. So 1, 2, 3, 4, 5, 6. So C to D, C to D is 60 Newton upward. Then D to E 10 Newton upward. D to E 10 Newton upward. So this completes our vector diagram D to I will note down this as vector diagram. What is the use of vector diagram? This vector diagram gives us the magnitude and direction of the resultant. How? The direction is from A to E, from first point to E point. So first point is A point, A to E is the direction. Now in this case A to E is upward. So this is upward and that is 5 centimeter. A to E is 5 centimeter and 1 centimeter is 10 Newton. So 5 centimeter means 50 Newton. So this is our resultant R. So from vector diagram we got the resultant in its magnitude and direction. 50 Newton upward in this case. Now this is not enough. The four characteristics of forces are its magnitude, direction, point of application and sense. We got magnitude and direction, but what is about the location of the resultant? For that we will have to follow the next steps which is known as third step is to draw a polar diagram. Polar diagram. What is polar diagram? Let us see. For that again draw this vector diagram as it is. So I am drawing the vector diagram as it is. This is A, this is C, this is B, this is D, and this is E. Now select any point which is known as pole, anywhere, either right side or left side. Select a point which is known as pole, mark it as O. O is pole. Join this pole to all the points on this diagram one by one. So I am joining one by one all the points to this pole. Join the points on this diagram, this pole. I am purposely using different color so that you will understand it better. Joining all the points on this diagram with the pole. This is known as polar diagram. Now, coming back to the space diagram. Actually, you can draw on this space diagram as it is, but this is the problem. First problem, I will again draw this space diagram. Means I am extending or projecting the lines to draw the next diagram, which is known as funicular polygon. Okay, now this is the space A. In space A, draw a line parallel to OA. Now, parallel to OA means this line from this diagram. Anywhere you can draw, but see that the first force, this is parallel to OA, and the point where this line crosses the first force, mark it as 1 point. Now, from point number 1 in space B, draw a line parallel to OB. So this is the line from the polar diagram. I'm drawing parallel to OB, just horizontal line, and I'm drawing line parallel to OB from this point to cut the second force in point number 2. This is parallel to OB, and to cut the line second force in point number 2. Now from point 2 in space C, draw a line parallel to OC. From point 2 in space C, draw a line parallel to OC. So this is the line parallel to OC. To cut the third force in point number 3. Now from point 3 in space D, draw a line parallel to OD. I will repeat. From point number 3 in space D, draw a line parallel to OD. To cut the fourth force in point number 4. To cut the fourth force in point number 4. This is point number 4. This line is parallel to OD. Now from point 4, draw a line parallel to OE in space E. From point 4 in space E, draw a line parallel to OE. I am drawing line parallel to OE in space E and extend this last parallel line drawn and the first parallel line drawn, that is in this case OA. So extend the line first and last parallel lines to intersect each other. So this is the point of intersection. This point is important because through this point the resultant which is 50 Newton upward passes. So this is the upward resultant R, and its distance from the say first force. Just measure this length from the first force, and as 1 centimeter is equal to 1 meter, convert it to, and distance is say x is equal to, here it is 6.4 meter, 6.5 meter, not 6.4, it is 6.5 meter. So this completes the diagram which is known as funicular polygon. Funicular polygon. So here the last step, fourth step, was funicular polygon. So in short, there are four steps to solve the problem of finding resultant of non-concurrent forces. First space diagram, then vector diagram, then polar diagram, and fourth is funicular polygon. Now we will solve the same problem by analytical method. Now to start with, same problem we are going to solve by analytical method. Now resultant R is equal to algebraic sum of all the forces. Here I will assume upward force positive and downward force negative. So R is equal to 20, which is plus as it is upward, minus 40 plus 60 plus 10. So here I will get 60 plus 10, 70 plus 20, 90 minus 40 plus 50 Newton, or in other words 50 Newton upward. So R is 50 Newton upward. Now again there is a question of where the R is acting, the location of the resultant. To find the location of the resultant, we will use this known as Varignon's theorem. Varignon's theorem. This theorem means, it states that algebraic sum of all the moment of all the forces about a point is equal to moment of their resultant about the same point. I will repeat, algebraic sum of all the moment of all the forces about any point is equal to moment of their resultant about the same point. Now I will assume all clockwise moment positive, all anti-clockwise moment negative. I will consider point A itself on the first force, that is 20 Newton force, and I will take moment of all the forces about that point, and I will make the algebraic sum and I will equate it to the moment of the resultant about same point, that is A point. So to start with, 20 into 0, As 20 passes through A, the distance is 0, so 20 into 0 plus 40 into 2, it is a clockwise movement, so I am writing it as plus, minus 60 into 5, this is anti-clockwise movement, 60 into 5, minus 10 into 10. See, the distance between the force 10 and point A, perpendicular distance is 10 meter. This is equal to 50 into say x1. We know the magnitude of the resultant, so that is 50 into x1 is the distance of the resultant from point A, which is not known. So 80 here minus 300 minus 100 is equal to 50 x1. So it is minus 320 is equal to 50 x1. It means minus sign indicate the resultant is producing anti-clockwise movement. Minus sign indicates R is producing anti-clockwise movement about A, and R is upward. R is upward. So to produce anti-clockwise movement about A, resultant must be on right side of A. So R is on RHS of A. Then only it will produce anti-clockwise movement. And the distance x1 is equal to 320 divided by 50, that is 6.4 meter. So resultant lies at a distance 6.4 meter from this first point somewhere here. Six 6.4 meter. So this is R, which is 50 Newton upward, and this x1 that we calculated as 6.4 meter from A on the right side, which is tallying, the answer is tallying with our solution by graphical method. Now, for the time being, I will consider a point, say B, point B on the force of 10 Newton. I will apply the same Warington's theorem, that is sum of all the moments, algebraic sum of all the moments about a point B is equal to moment of their resultant about the same point. So now taking moment about B, taking moment about B, all clockwise positive, anti-clockwise negative, 20 into 5, sorry, 20 into 10, 20 into 10, because we are taking moment up to B, 20 into 10, which is clockwise, so positive, minus 40 into 8, anti-clockwise, so negative, plus 60 into 5, again clockwise positive, plus 10 into 0, because 10 Newton passes through B. This must be equal to, say, 50 into, now I will assume it is x2. So this is 200 minus 320 plus 300 is equal to 50 into x2. So 50x2 is equal to 180. Here the resultant is producing positive movement and it is upward. So to produce positive movement, that is clockwise movement about B, the upward resultant must be on LHS. So plus sign indicates R is producing clockwise movement about B. So R must be on LHS of B to produce clockwise movement because R is upward, and therefore x2 is equal to 180 divided by 50, that is 3.4 meter. So from B the distance of the resultant must be from B, it is x2 3.6 meter, not 3.4, it is 3.6 meter. 180 divided by 6, it is 3.6 meter. So irrespective of the point, we got the same answer. X1 we got 6.4, which is from the first force, that is 20 Newton force, and x2 is 3.6 meter, which is from B. So if you add this 6.4 and 3.6, you will get 10 meter, which is tallying. So by this way we can locate the resultant by using Waddington's theorem. Now this completes the problem. Thank you.